Hey guys, this is going to be a quick review video over everything for 5.6, so for your major quiz tomorrow. So number 1, find the domain and range of the rational function graph below. Well, for domain, we're looking at our x values, so notice you can have anything but where that asymptote is. Okay, so that asymptote is at -4, so everything but -4 can be included in the domain. So not that one and not that one. We need -4 to be excluded. Okay, and then looking at the range going from bottom to top, everything except that horizontal asymptote can be included. So everything except -2. So right here, they excluded the -2 from the range, and so that is the correct answer. All right, next one. Determine which of the rational functions given below has the following features. So let's start with our x-intercepts. Our x-intercepts need to be at -2 and 4. Well, what do we know about x-intercepts? X-intercepts are where y equals 0. In order for this function to equal 0, the numerator has to equal 0, right? Because 0 divided by any number, doesn't matter what it is, equals 0. So for x-intercepts, you're always just looking at where does the numerator equal 0? What makes the numerator equal 0? So right here, this would be x equals -5 and x equals -1. Those would be your x-intercepts. Well, that's not right. So look at your x-intercepts. They're -2, so I should have x plus 2 in the numerator, and +4, so x minus 4 should be in the numerator in order to get those x-intercepts. There's actually only one answer with that in the numerator, so from there we're actually done, but let's keep going. The y-intercept is going to be where x equals 0, so if I plug in 0 for x here, 0, 0, 0, 0, plug in 0 for all of the x's, I get 2 times -4 over -5 times -1. That gives me -8 over +5. So again, that one's correct. Vertical asymptotes, those come from the denominator being 0, right? So set your denominator equal to 0. That would give me x equals 5 and x equals 1. Perfect. So set those factors equal to 0 and solve for x. Horizontal asymptote at y equals 1. In order to get a horizontal asymptote at y equals 1, first of all, your degrees would have to be the same. Well, if I were to FOIL this out, my leading term in the numerator would be x squared, and my leading term in the denominator would also be x squared. I don't really care what happens after that. The horizontal asymptote is only determined by the leading terms when the numerator and denominator are in standard form. So since the degrees are exactly the same, we would take the coefficients and divide. 1 divided by 1 is 1, so therefore the horizontal asymptote would be y equals 1. Again, you didn't have to do all of that because we could tell just based on the first part what the correct answer was. But just to show you, that's how that would work. Skipping over to number 5, they're asking for the horizontal and vertical asymptotes. So vertical asymptotes, right here and right here. If you have trouble remembering whether that should be a x equals or a y equals, remember you may have learned this in Algebra 2, but it's a little trick to remember whether it should be x equals or y equals, and that is Hoy-Bucks. So Hoy is saying horizontal gives you a y equals. Bucks is saying vertical gives you, why did I write bus? Is saying vertical gives you x equals. Okay, so since we're looking at vertical, we should have x equals. So x equals -3 and +3. X equals plus or minus 3. Okay, so that's gonna knock out that one. For my horizontal asymptote, I should have a y equals, and that one is at 1, so y equals 1. So that's pretty simple. That one's right there. All right, domain and interval notation. So remember, the only things that can restrict your domain is your denominator cannot equal 0. So x plus 9 cannot equal 0. And it makes sense because we know that the graph is going to have a vertical asymptote because of that denominator at -9, right? So again, your domain is going to have that number restricted because of the vertical asymptote. And then also because the denominator cannot equal 0. That's why you get a vertical asymptote in the first place. Another thing that can restrict domain is, remember, whatever's underneath the square root has to be greater than or equal to 0. However, we're not dealing with radicals right now. We're just dealing with fractions. Okay, so set your denominator not equal to 0. X cannot equal -9. We don't want this one with the square brackets because that means that the -9 is included, right? That's saying include the -9. We need the one with parentheses because we want it to stop right before -9 and then start after -9, not including the -9. You would do the same thing on number 7. I'm skipping that one, but you do the same thing on 7. Just set your denominator equal to 0. You're going to have to factor that one, but that's it. It's just whatever numbers make the denominator equal to 0. Same thing on number 8, but I do want to mention this one just for a second. So remember, it's whatever makes your denominator equal 0 cannot be in the domain. Well, this is the sum of squares, so I cannot factor it. I cannot factor that. So let's just subtract the 100 instead. And then let's take the square root of that. X cannot equal plus or minus the square root of 100 is 10, and the square root of -1 is I. Well, I'm not really concerned with imaginary numbers right now, right? I'm only, my domain is all real numbers. And so this does not restrict anything from the domain. No restrictions. Because all I got was imaginary numbers. So it's going to be negative to positive infinity. Okay, let's think. A lot of us would be tempted to put -10 or 10. If you plug in 10 to the denominator, 10 squared plus 100, well, 10 squared is 100. So that gives me 200. That's not an issue. Restrictions are things that cause problems. That is not a problem. Having 200 in the denominator is fine. Our restrictions, we get them here because we can't divide by 0. Well, in order for x squared plus 100 to equal 0, x squared would have to equal -100, right? -100 plus 100 is 0. This would have to be -100. But anytime you square a number, doesn't it become positive? Right? Anytime I square a number, it becomes positive. So because this is going to be a positive plus a positive, there's no way for it to ever equal 0. So no restrictions on that, where we have an x squared plus 100 in the denominator. Number 9 is talking about end behavior. So first, as x approaches -infinity, that's just talking about as you go far, far to the left, what is your function approaching? What is the y value getting close to? So as I move to the left, I see my curve is approaching that horizontal asymptote, which is at 3. So this is approaching 3. And then as I move to positive infinity, so as I go to the right, what is my curve approaching? Again, that horizontal asymptote at +3. All right, looking at number 12. So this is saying as x approaches -5 from the left. That's saying from the negative side, which is from the left. So as I move towards -5 from the left, what is my function approaching? So here it is. As I move towards -5 from the left, that is going up, up, up to infinity. Now as I approach -5 from the right, so right here, I'm approaching it from the right. So here's what's happening to my curve. It's going to -infinity. So positive infinity, negative infinity. On these, we are getting our vertical asymptotes. Vertical asymptotes are caused by the denominator, anything that makes the denominator equal 0. So in the in number 13, that's pretty easy. Just set those factors equal to 0, solve for x. On number 14, same thing, except you have to do the factoring first. This would be x minus 6 over, this is difference of squares, so it factors into x minus 3 and x plus 3. Now set those factors equal to 0 and solve for x. You should get positive and negative 3. You can also do this particular one, by adding the 9 over and then taking the square root. But don't forget the plus or minus there when you take the square root. So x equals plus or minus 3. So either way, we get positive and negative 3. Same thing on 15 and 16, setting the denominator equal to 0, solving for x. But on 16, we might need a little review on factoring, so I will go over it. We're looking for vertical asymptotes. So again, the denominator equals 0. 2x squared plus 11x plus 5 equals 0. To factor this, you can use whatever method you're comfortable with. I'm going to do the AC method. It seems to be what people are favoring. So 2 times 5 is 10. So I'm looking for two numbers that multiply to 10 and add to 11. So that's 1 and 10, 2 and 5. I could do positive 1 and positive 10, so that'd be x plus 1, x plus 10. But because I multiplied by this 2 at the beginning, I need to divide by 2 right here. This is called the AC method. All right, so you can leave that as x plus 1/2 and set that equal to 0. 10 divided by 2 is 5, so that's going to be x plus 5 and set that equal to 0. Solve for x. X equals negative 1/2. X equals negative 5. Negative 1/2 and negative 5. If you wanted to check to make sure that was correct, you could plug those x values back in here and make sure that it comes out to 0, right? Because that's what vertical asymptotes are. It's where the denominator equals 0. What causes the denominator to equal 0? To horizontal asymptotes. So there's 3 possibilities when it comes to horizontal asymptotes. First of all, if your degree is greater in the denominator, so when I say degree, I'm talking about the largest exponent. So let's say I have x cubed plus 5x minus 3 and x to the 4th minus 2x plus 1. So when I say degree, I'm strictly talking about this largest exponent. And everything depends on that when it comes to horizontal asymptotes. If the degree is greater in the denominator, like it is here, it's automatically y equals 0. Your horizontal asymptote is automatically y equals 0. If they are equal, if they had been equal, let's say like 3x minus 5 over 1 plus 2x. Okay, now my degree is 1 and 1, always looking at the one with the largest exponent. So I'm only concerned with these two. So if they're equal, you just take the coefficients and divide them. So y equals 3 divided by 2, or 1.5 is your horizontal asymptote. And then your other possibility is that the degree in the numerator is greater. So I could just take this one and flip it around. X to the 4th minus 2x plus 1, if that's in the numerator. Now I have x cubed plus 5x minus 3 in the denominator. Now I have no horizontal asymptote. Sorry. If the degree in the numerator is greater than the denominator, you have no horizontal asymptote. You will have an oblique, or another word is slant, asymptote. And to get it, you will use division. Divide to get the equation. Okay, so synthetic division, long division, whatever you want to use, or whatever you need to use to find that equation. Okay, those are the only possibilities, so let's look at it. Right here, horizontal asymptote, not vertical, horizontal. I see I've got a degree of 1 in the numerator, 2 in the denominator. Since the denominator is greater than the numerator, it's 0. The reason that happens is because x squared is going to increase so much faster than just plain old x, that, think about it, if I'm dividing 10 by 1,000, or 100 by 10,000, that's going to get close to 1. The denominator is increasing so much faster than the numerator, it is going to approach 0. All right, this one, our degrees are equal, so we simply take 28 divided by 7, we get 4. Y equals 4. That's it. That is it for horizontal asymptotes. And this is our case number 3, where the numerator degree is greater than the denominator. In this case, you want to use division. Since this is linear, we can use synthetic division. So 5 goes in the box, and then your coefficients, 1, 8, negative 5. And then you do synthetic division to find the equation. 1, 5, 13. Okay, the remainder doesn't count, so that's y equals x plus 13 is your slant asymptote. So that's good practice, but notice that they actually didn't ask for what the equation was. On this one, you can just say there is no horizontal asymptote. But if they did ask for it, this would be the equation of the slant asymptote. At 21, because you may have not seen this worded this way or thought about it this way, it's asking the graph of f of x will behave like which function for large values of x. So large values of absolute value of x, that's just saying, that's another way of saying the end behavior. And end behavior is what determines your horizontal asymptotes. End behavior determines your horizontal asymptotes, right? Because that's exactly what a horizontal asymptote is. It's a line that's saying your curve approaches this at the ends. Your curve approaches this line at the ends. So all this question is saying is, what is your horizontal asymptote? That's all it's asking. What is the horizontal asymptote? Okay, so degrees are the same. 10 divided by 13. No x's, right? Because if I were to divide this out, my x's would cancel. You're just taking the coefficients. 10 divided by 13. Okay, this one a little tricky. You've got to identify your asymptote. Notice the degree is greater in the numerator than the denominator. That means you have a slant asymptote, so not those two. That means you have a slant asymptote. So you need to use division to figure out what the equation is. You can't use synthetic on this one because your denominator, what you're dividing by, is not linear. It's not just x minus 3, something easy like that. So you need to use long division on this one. So let's kind of go over that. 2x squared minus 4x plus 3. In the box, I've got 4x cubed plus 3, insert a 0x here, 0x squared plus 3x plus 3. All right, so I look at the first two terms and I divide. 4x cubed divided by 2x squared gives me 2x. Well, looks like I have my answer, right? I don't even have to keep going. But if you did keep going, you would multiply 2x by that whole thing, 4x cubed minus 8x squared plus 6x. Change the sign, draw the line, keep going. 8x squared minus 3x, drop the 3. Do it again. 8x squared divided by 2x squared is 4, so plus 4. And that's all you need. So there's the equation for your slant asymptote. On 23, vertical asymptote. So remember, vertical asymptote is where your denominator equals 0. So simply x equals 0 is your vertical asymptote. So we can knock out the last one. Your horizontal or slant asymptote comes from the degrees. The degree on this one is greater in the numerator than the denominator, so we need to divide. You don't have to do synthetic or long division on this one, although you could do synthetic division with 0. You could do that, but it's even easier to just do 2x squared over x plus 7 over x. This is actually your remainder, so that doesn't actually affect your asymptote at all. This one, the first term, reduces to just 2x. So your slant asymptote is y equals 2x. I'll do this one on your own. You're getting your asymptotes. To get your vertical asymptotes, remember you're going to need to factor the denominator and set those factors equal to 0. So for all of these problems where you're given a feature of the rational function and you're trying to find the correct function, this is kind of like our homework check question from Tuesday where we were matching. So the x-intercept is at 4. So let's discuss these features. How do you get what causes the x-intercepts? The numerator equaling 0. Right, numerator equals 0 will cause the whole function to equal 0. So which of those would cause, which of those would give you an x-intercept at 4 when the numerator equals 0? That would be this one. If I set that equal to 0, I get x equals 4. Number 26 is talking about the y-intercept, and that is when x equals 0. So you plug in 0 for x to get that value. I'll let y'all do that one on your own. Y-intercept is where x equals 0. I think we've already talked enough about our asymptotes for you to figure these out. The 27 is talking about horizontal asymptotes, so remember that's dependent on your degrees. 28 is talking about the vertical asymptote, so that is dependent on the denominator equaling 0. What causes a hole? That's when your factors, you have a factor in the numerator and denominator that cancel. So when factors cancel, that's where you get a hole. Okay, and then this one is pretty similar to what we did on, I think it was number 2. Okay, so just your x-intercept, remember that's in the numerator. Y-intercept is where x equals 0. Vertical asymptote, you should have x minus 1 in the denominator for that. Horizontal asymptote at y equals 1 means your degrees must have been the same and the ratio of the coefficients should be 1. The ratio of the coefficients should be 1. Okay, I guess I can do this one with you. All right, x-intercepts. If I have an x-intercept at 3, that means I need to have x minus 3 in the numerator. If I have one at 5, that means I should have x minus 5 in the numerator. So that knocks out that one and that one because they have plus instead of minus. Those would give me x-intercepts at -3 and -5. Okay, my y-intercept is at 15. So if I plug in 0 for x, I should get 15. Okay, so the numerator gives me 15 here. The denominator gives me -1 squared is +1. So that's 15. This one, if I plug in 0, I get -3 times -5. And then denominator is just -1. So that's 15 over -1, which is -15. So I can already tell that this one is my answer. But let's keep going. Vertical asymptote at x equals 1 means I should have x minus 1 in the denominator. Both of them have x minus 1. So that's good. Horizontal asymptote, the degrees have to be the same. So this one's important. The degrees have to be the same. The degree in the numerator here is 2, because if I multiplied this, I would get x squared. The degree in the denominator, if I FOILed that, would also give me x squared. However, on C, I would get x squared in the numerator, but in the denominator, I would just get x. So this one would actually have a slant asymptote, not a horizontal asymptote at 1. So again, that's another reason why B is the correct answer. All right, on the next few problems, we're talking about transformations of these functions, of rational functions. So let's review that. If you have something like this in the denominator, something being added or subtracted to the x, that's going to make your graph shift to the left or to the right. If you have minus, it's shifting to the right. If you have plus, it's shifting to the left. So this one is going to go to the right 4. And in fact, that also tells you that your vertical asymptote should be at positive 4. Because if my vertical asymptotes always start at 0, if I shift it to the right 4, now it's at positive 4. So horizontal shift 4 units to the right. Okay, and then the plus 3 at the back, which, sorry, that font is so small, but that's going to make your graph shift up 3. If it was minus, it would go down. It's plus, so it goes up. So it's going to make your graph shift up 3. All right, so that is the correct answer. Number 32. We've got a negative in front that causes a reflection. Okay, so reflecting, it really doesn't matter whether you say across the x-axis or the y-axis, just because it will give you the same result. But we do need that reflection, so not that one. The 6 in the numerator is going to cause a vertical stretch by a factor of 6, so that leaves us with B. A number in the numerator there is going to cause a vertical stretch. All right, number 35. So think about your transformations. You can do this multiple ways, but with my transformations, this is telling me it's going to shift to the right 1, and then this minus 2 makes it go down 2, so right 2, down 2. That tells me that my vertical asymptote is going to be at 1. All right, so if I shift it to the right 1, that means my vertical asymptote should have moved to positive 1. If I shifted down 2, that means my horizontal asymptote should have moved down 2 to negative 2. Okay, so I should have that. Now we should know that x squared, the parent function, has the shape. Both curves are above the horizontal asymptote like this. Unless it gets reflected over the x-axis, then they would be below. Then they would be below the horizontal asymptote. So let's look at our options here. We need our vertical asymptote at 1, so this one's good, this one's good, that one's good, and I'll get to the one on the next page, I guess, in a minute. My horizontal asymptote's at negative 2, this one's good, this one is at positive 2, so that's not it. This one is at positive 2 as well, so that's not it. Let's see if this one checks out on everything else. So it's opening, it has both curves in the top, so that's good. Now, let's check just one more thing, and that is either the x-intercept or the y-intercept or something like that. I can see my y-intercept on this one is at negative 1, so let's see if that's where my y-intercept is supposed to be. To find your y-intercept, you plug in 0 for x. So negative 1 squared is 1. 1 divided by 1 is 1. And that should be 0. So actually my y-intercept should be at 0. Oh, sorry. I wrote the wrong number down there. It should be minus 2. Okay, 1 minus 2 is -1. So good, that checks out on everything. Let's look at option D though, since I couldn't see it, and just make sure that that's not the answer. All right, I can automatically tell this is not the answer because my curves are in the bottom. Also, my y-intercept is not at -1. And let's see, was there anything else? My vertical asymptote was supposed to be at +1. So multiple things make that one incorrect. So A is the correct answer on this one. So just by getting my transformations, which also tells you your asymptotes, and knowing the shape should be both sides up. And then I double checked, I just found my y-intercept to kind of double check my answer on that one. All right, and this one you can find your asymptotes first. That's what I would do at least. My vertical asymptotes, let's see, that's where the denominator equals 0. So let's factor this first. That's x minus 5, x plus 1. So I should have vertical asymptotes at x equals 5 and x equals -1. X equals +5, so not that one. +5 and -1, so that's good. X equals +5 and -1, that one's good. I can't see the last one, so I'm just gonna go with these three for right now. Horizontal asymptote should be at 0 since my degree is greater in the denominator, so y equals 0 is my horizontal asymptote. 0, 0, 0, they're all at 0, so that doesn't help me. Now that I've got my asymptotes out of the way, let's see what the difference in these two is. The difference in these two is where the curve is located. This one is at the bottom, this one is at the top. This one is going down this way, this one's going up. So what can we do? We can plug in some values of x, plug in some values for x to see what the y values are supposed to be at that x value. So I'm going to plug in, let's say, it doesn't really matter. I'm going to plug in -2. So 4 times -2. I'm finding f of -2. If I plug in -2, I'm going to use this as my denominator. So that's -2 minus 5. -2 plus 1. Okay, so I should have a negative, it's a 1 point something, negative y value at -2. So -2, comma, -8/7. So on this one at -2, right here, I have a positive y value. So that's not it. At -2 on this one, I have a negative y value, and it's actually at -1 point something. So that one checks off there, and that also marks out this one. That's not correct. It's going in the wrong direction. So let's see if this is the answer or if we need to consider D. Let's see what D has going on. D has the vertical asymptotes in the wrong places. They were supposed to be at +5 and -1. So that means C is your answer. I could get it just by getting my vertical asymptotes and then plugging in 1 point for x to see where that curve should be. You could have also plugged in +2 here if I had plugged in +2. Let's see what I would get if I plugged in +2. I get 8/-9. So that should be a negative y value at +2. So 2 -8/9. So a negative y value at +2. And there it is, a negative y value at +2. So just something to consider when you're determining the graphs. Just plugging in a value of x and checking that. All right, number 37. As you can see by looking at your options, you're going to have a slant asymptote on this one. You should be able to tell that also because the numerator, the degree of the numerator is greater than the degree of the denominator. So how do you get that slant asymptote? You get that by setting your, by division, dividing your numerator by your denominator. You could, again, do synthetic division here with 0 in the box, or you can just do x squared over x plus 6x over x. You don't need to do the 9 over x because that is your remainder. 9 over x doesn't affect your asymptote. Okay, so that gives me x plus 6 when I reduce that. So your slant asymptote is y equals x plus 6. So let's see which one of those has a slope of 1 and a y-intercept of 6. Slope of 1. Well, this one has a slope of -1. Well, at least the slope is negative. These two both have a positive slope. Y-intercept is positive 6, so that's not this one that has a negative x-intercept. These are counting by threes because 3, 6, 9, 12, 15. So this is 6. So this has the correct slant asymptote. Let's see if it has everything else it's supposed to have. We need to have a vertical asymptote at x equals 0. Setting your denominator equal to 0 just gives you x equals 0. So that one has that, vertical asymptote. So slant asymptote good, vertical asymptote good. All of our asymptotes are looking great. Let's check this x-intercept. Remember your x-intercepts are where your numerator equals 0. So how about I factor that numerator to find my x-intercepts. So x plus 3, x plus 3, or just x plus 3 squared. Well, that's just a 0 of -3, multiplicity 2, which we talked about earlier this year. Sorry, not long ago at all. Multiplicity 2, and that tells me it should bounce at -3. Well, look, perfect. I have a 0 at -3 and it's bouncing there, so that's exactly what we want. Let's check our last option just to make sure we didn't miss anything. This one has a negative slope for the slant asymptote, so that's not correct. So your answer was B there. So for the rest of these, just continue in that way, checking your vertical asymptotes, your horizontal asymptotes. Look at your y-intercept if you need to, and your x-intercept if you need to help you determine which graph is the correct choice. All right, so I think that's all I need to go over. Good luck on your quiz tomorrow.